Hello everyone, welcome to my YouTube channel TechSpot. This is me, Harish Gaupale. So basically in today's video, we are going to discuss about the working and functionality of SR latch by using NAND gate and the RTL design implementation of SR latch by using NAND gate on a Vivado tool. Let's get first discussed what exactly the SR latch is. You can see the block diagram of SR latch. It has two inputs, that is S and R, and two outputs, that is Q and Q bar. Basically it is one of the asynchronous sequential circuit, means it works irrespective of any clock, and it is a storage container which store 1 bit of information. As name suggests, S means set and R means reset, and S is denoted by logic 1 and reset is denoted by logic 0. Basically it samples data on the levels. Okay, now let's discuss the block diagram of SR latch. Okay, as it has having two inputs, so we can have four combinations. The four combinations are 0 0 0 1 1 0 and 1 1. Besides this logical diagram, you can see the truth table of NAND gate. Basically this truth table of NAND gate helps us to understand the functionality of SR latch. Okay, let's discuss what this truth table of NAND gate says. If you see, one of the input is 0, then my output is 1. Here you can see A is 0, my output is 1. We don't need to worry about another input. Here is also A is 0, my output is 1. Here is also B is 0, my output is 1. When my both A and B are 1, then only the output is 0. So what it says, if one of the input is 0, means output will be 1. This will help us to understand the functionality of SR latch. Now let's discuss the first combination. Here the first combination we are going to discuss, where my S is 0 and R is 1. Okay, according to the truth table, if my one of the input is 0, then my output is high. So here you can see when my S is 0, means I can say my output Q is high. Now this Q is going feedback for the second NAND gate, where my R is 1. So 1 and 1, according to the truth table, it is 0. So here my Q bar I got 0. This obviously I got the complement. My Q is 1 and Q bar is 0. That means my SR latch is in set state. Okay. Now let's discuss another combination where my S is high and R is 0. So again, according to the truth table of NAND gate, if my one of the input is 0, then output is high. So you can see my R is 0. That means here I don't need to worry about this feedback. I can directly say my Q bar is 1. So obviously my Q bar is 1. So that is going as feedback to this first NAND gate, where my S is 1. So obviously 1 and 1, I got Q is equal to 0. This Q bar is 1. So complement of Q bar, that is Q, is equal to 0. Here again, that means my SR latch is in reset state. Okay, because Q is equal to 0, I got. Okay, now let's discuss the third combination, where my S and R both are 1. Now S and R both are 1. So here for this first NAND gate, my Q bar is the feedback. For the second NAND gate, Q is the feedback. So we cannot directly predict the value, output value. Okay, so here Boolean expression which helps us to get the value of Q and Q bar. Okay, so for this Q, my Boolean expression is S and Q bar, because this Q bar is feedback for this first NAND gate. So the Boolean expression you can see, Q is equal to, my value of S is equal to 1. So 1 and Q bar and the whole bar. Now if we solve this Boolean expression, so according to the De Morgan's theorem, this whole bar will break, and the expression is 1 bar plus Q bar and bar. So again 1 bar means 0, and this Q bar will cancel. Okay, and the double complement of any variable is the same complement. So here you can see I got the output Q. Okay, similarly for this Q bar, my Boolean expression is R and Q and the whole bar. Here you can see Q bar is equal to value of R is 1 and Q whole bar. So again the bar will break, so 1 bar plus q bar will break, so 1 bar plus q bar. Obviously 1 bar is equal to 1 bar means it is 0, so 0 plus q bar is equal to q bar. Now let's put the value of q. If suppose my q is equal to 0, okay, so here 0 0 and 1, obviously as per the truth table 0 and 1, our output is 1, so my q bar is 1 again. So this q bar is going to feedback for this first NAND gate, so 1 and 1 or 0 means the value, the value I have provided 0, so I got the output as a 0 only. Okay, so that means my SR latch is in hold state. Okay, now the fourth combination is 0 0. So the fourth combination is 0 0. So when my SG is equal to 0 and R is equal to 0, according to the truth table of NAND gate, if one of the input is 0, that means output is 1. So you can see when S is equal to 0, I can directly predict my Q is equal to 1. Okay, and here also R is equal to 0 means Q bar is equal to 1. If you see Q is not the complement of Q bar and Q bar is not the complement of Q, that means there is some problem in the design. So we can say when my S is equal to 0 and R is equal to 0, my SR latch is in the invalid state. Okay, so what we have discussed here, we have discussed all the combinations when my S and R both are 0 0. That time my SR latch is in invalid state. When my S is 0 and R is 1, that means my SR latch is in set state. When my S is 1 and R is 0, that time my SR latch is in reset state. And when both S and R is 1 1, that means my SR latch is in hold state. Okay, now let's jump for the RTL design implementation of SR latch by using NAND gate on Verilog. So here you can see my screen. I have already written and Verilog code for the RTL design implementation of SR latch. Okay, so let's go through each line of code and understand. Okay, here you can see my tick time scale is 1 nanosecond divided by 1 picosecond, and my module name is SR latch. And as we have seen the inputs and outputs of SR latch in block diagram as well as in logical diagram. So here also I have taken the same input, that is S and R, and output, that is Q and Q bar. As it is a sequential circuit, so in Verilog we have sequential procedural block, that is always at the rate, and we are having inputs, that is S and R. So you can see always at the rate S or R begin. And here I have used the case statements. We know the functionality of case statement. Case statement says that for every possible output we have to provide every possible input, and inside the case statements I have built a behavioral logic. Okay, now let's understand the logic. So when my S and R both are 0 0, so according to the truth table, if my S and R both are low, then it is in invalid state. So you can see I have assigned X to the output Q and Q bar, because we don't know the output can be anything. So here I have assigned input as a X. Okay, as it is a behavioral logic. Now when my S and R, S is 0 and R is 1, so that time my SR latch is in a set state. So for that I have assigned 1 to the output Q as 0 to the output Q bar. Okay, when my S is high and R is 0, R is low, so in that condition my SR latch is in a reset state. So you can see I have assigned 0 to the output Q and 1 to the output Q bar. Okay, when my S and R both are high, then my SR latch is in hold state. So I have assigned Q to the output Q and Q bar to the output Q bar. Okay, when I execute this code, then we will get this kind of schematic. To save the time, I have already executed, so I have already the schematic. You can see my input S and R, and these are the muxes. These muxes occurred generates due to the case statement, and at the end it is a latch. So you can see the latch for Q and Q bar. Okay, now to verify this simple SR latch, I have simply written a TB code also. Now let's discuss that also. Here you can see my module name, again TB for SR latch, and here also I have taken the same name of the inputs and outputs of SR latch, that is S, R, output, that is Q and Q bar. Now here you can see the instantiation name SR latch, the instantiate name latch DUT, and dot wildcard operator here I have used. As in my so many videos I have told you, if our design inputs and test bench inputs are same, then we can use this wildcard operator, which will automatically instantiate all the signals. Okay, and inside the initial begin I have given all the combination values. Okay, again when we run the simulation, okay, as I have already run the simulation, okay, we can get the waveform. So as I already run this, I am already having the waveform. We will discuss that. I did all these things to save the time. Okay, so now as I have explained you in my truth table, and I'll explain the functionality. When my S and R both are low, that means it is in invalid state. So you can see the output Q and Q bar, that is unknown. As I have implemented this logic in my design also. When my S is low and R is high, so you can see it is in a set state. So you can see Q is high and Q bar is low. When my S is high and R is low, so that means my SR latch is in reset state. So you can see the Q is low and Q bar is high. And when both S and R is high, then my output Q and then my SR latch is in hold state, means Q bar will hold the previous value. Q is holding previous value, Q bar is holding previous value. You can see that. Okay, so basically in this video we have discussed the functionality and working of SR latch and RTL design implementation of SR latch. So basically if you are watching this video, then please click on the like button, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Thank you so much.